All right, ladies and gents. Well, this video is a little bit different than some of our other videos. This is a kind of video walkthrough of the participation assignment for logistic regression. Talking through not necessarily all the details within that assignment, but really trying to get to the place where we can look at some interpretations and focusing on the way that we can interpret this. Because again, logistic regression is kind of a beast in terms of all of the different interpretations that it can have and some of the issues with interpretation that logistic regression can have. It's really pretty nasty. So we're gonna run through that and kind of see what we get. This is not going to be polished in any way. I'm just going to be kind of glancing through this assignment, trying to get what I can, and just going through this as quickly as possible to help give you all something that may help with your interpretations if you want to consider that. So the first thing I have to do after the data set's in is I got to go to transform and compute variable. Again, this is going to be very unpolished, so take it in stride. I'll do binary work stat. Add work status. Where's work? Right click and go to labels. Work status, and I think we did equals. I believe the original work status is 1. So what I'm trying to do is get a binary variable to represent 1, the working, and then 0 is going to be housewives all together. So working versus housewives is the outcome our book uses, with 1 being working. Though I do think the textbook actually codes this the opposite way. But let me see, in our assignment, I think we do equals 1. So we actually code it the opposite way from the textbook, which is fine. We'll get the opposite results, but that's okay. All right, so I'm going to go regression, binary logistic. I'm going to drop in work status. I'm going to drop in my attitudes. So I need, what variables do I need here? Attitude scale, so attitudes, locus of control. Okay, none of these are categorical. No, I don't really care. I could do a couple of these. So go to options and do my confidence interval. I'll do the confidence interval. These are categorical. Don't care about style. We're not using bootstrap, so just options here. Let me see. Ration history. We could do Hosmer Lemshaw. I think we do that later. I'm not going to worry about that right now because it's not as important. Do okay. All right. So we'll just run that. And all right. So now we have the table. Is that it? Just run, press continue. Okay to run the analysis. Okay, cool. Dependent variable has more than 2 non-missing. 2. Well, okay. Can't. Weird. Well, let's try that again. Binary logistic, dependent variable, work status. Oh, I see. I used the original work status instead of the binary work status. That's my bad. Okay. So I'm not going to edit that out. Y'all can see that happens sometimes. I need the binary version for binary logistic regression is what that's yelling at me about. And I can go, again, there's a lot of crap that's in these outputs. So you don't necessarily have to worry about it. Maybe one thing I could check is omnibus test of the model. That says that all of my variables are statistically significant, blah, blah, blah. Okay. So this is our main table for interpretation, and I think this is what we were asking about, or what some students were asking about. So this is what we're focusing on, here. So it's important to remember that 1 represents working women and 0 represents housewives when we're doing our interpretation. So for this particular interpretation, I have no statistically significant factors except for the attitudes of the role towards women, which is a statistically significant factor. And so let's see, incorporate in your interpretation significance. So that's the first thing. I guess I got lucky there. That's the first thing I'm supposed to look at. And I ignore the constant. I just look at significance. And what I might say is, of all of our variables, only attitudes towards women was a statistically significant variable. I can do the sign. So the sign indicates the direction of movement. So as attitudes towards the role of women increases, or becomes more conservative, according to our textbook, that's what an increase in this means, then the probability of being a working woman decreases. And that actually completely makes sense. As the attitude towards the role of women becomes more conservative as opposed to more liberal, the probability of becoming a working woman decreases, which does make a ton of sense, at least to me. Attitudes towards housework, we have as the attitudes towards, I normally wouldn't interpret these other variables, but just for practice, as attitudes towards housework increases, the probability of being a working woman decreases. As attitudes toward current marital status increases, the probability of being a working woman increases. Again, positive sign, so probability increases. And as locus of control increases, I believe that it is locus becomes more external, the probability of being a working woman decreases. Again, none of these things are statistically significant. That is, they might just be random noise. I don't have enough evidence to believe that they aren't just random noise. So I don't really trust any of those interpretations I just made, but that is how I would interpret based on the sign. Again, a negative sign means that as this goes up, the probability goes down, and our ones is working, so that is the probability of working goes down. So as this increases, the probability of being a working woman goes down. The positive would be as this goes up, the probability of whatever our one is, again in this case working, goes up. So as this variable increases, the probability of working goes up. Now, I don't interpret those. Again, the significance indicates how confident am I that this is different than just random noise. And for all except the attitudes of role towards women, I'm not particularly confident that this is anything more than random noise. All right. So the next thing I'm supposed to do is look at the odds ratio. So I remember my beta is not my odds ratio. My odds ratio is e to the beta. That's this one over here. And that indicates for a single unit increase in the role of women attitudes scale, the odds of being a working woman are 93%, the odds of being a working woman if you didn't have an increase in the attitudes of role of working scale. So there's a mild drop here, multiplicative. Again, the odds ratio is a multiplicative. And as I'm interpreting, I'm focusing on odds interpretation. So as the odds, or as the attitudes of role towards women increases by 1, the odds is 0.93 times the odds of the group of people whose attitudes towards the roles of women was not increased by 1, I guess is how that interpretation is. And again, that's a yucky frickin' interpretation. All right, and so I'm supposed to incorporate in my interpretation the other variables' impact on the interpretation. So this is tough when I'm talking through it because I'm talking through each point one-on-one, but when I'm writing this up, I'd kind of write all this together. So maybe I'd write all of the variables were not statistically significant, with the exception of attitudes towards role on women, which as it increases, reduces the probability of being a working woman. And in that case, I would then end that sentence with my ion and other variables' impact on the interpretation from the prompt. I would end that sentence with saying, that's the effect of the attitudes of role towards working women on the probability of being a working woman after accounting for the other variables. And that's the whole and other variables' impact on the interpretation is this particular interpretation is after accounting for all of the other variables in the model. And this may or may not be statistically significant. This may or may not be in the same direction, etc., without accounting for all those other variables, even though they're not statistically significant. So also consider, what does this practically mean within the context of the problem? Is it convincing enough to make a decision based off why or why not? So let's take those in order. What does this practically mean? Well, practically means that this stuff, at least with all these other things in the model and in the sample, didn't really contribute a whole lot. The attitudes towards the role of working women was statistically significant, but the effect seemed to be rather mild. I guess I don't know what scale this is on, but for a single point increase in this particular scale, the effect seemed to be rather mild in terms of size. So, from that perspective, what does this practically mean in the context of the problem? I do think, again, I mean, locus of control practically doesn't seem to be related to the probability of being working versus being a housewife. Attitudes toward the marital status doesn't seem to be related, which is kind of an interesting finding. I would have thought maybe this was related, but I guess not. Attitudes towards housework isn't related. Again, also kind of an interesting finding. Attitudes towards role of women is related, and this makes sense to me. And again, in the context of the problem, what does this practically mean? Well, it practically means like this kind of makes sense. This kind of is an understandable mechanism towards how this could affect the probability of a woman being employed. I think the employment status is more than 20 hours. Working more than 20 hours is how that's defined or operationalized. So again, for me, this does kind of make sense. But again, the effect is rather small per unit increase. Now, again, I don't know the scale, so I don't know exactly what that means. But that is something maybe I'd note is, per unit increase, that's a rather small effect, at least for me. Is it convincing enough to make a decision based off? Well, again, these other variables aren't particularly convincing. That is, they don't seem to have evidence that they're anything more than random noise. This one, the significance is a little bit more convincing, but again, the size isn't particularly large. So it's convincing in the sense that I do believe that attitudes towards the role of women does play an impact or is related to the probability of being working. But the size of that effect or the size of that relationship doesn't seem to be large. So it is convincing that there is a small relationship. That's what this convinces me of. Not convinces me that this is a massive factor, but convinces me that there's a small relationship, at least for a single unit change in the attitudes of the role towards women. Okay. Why or why not? Well, why? Well, it convinces me that there's a relationship because the p-value is really small. That is the probability that this happened by chance, and I know that's not exactly what the p-value is, but for our intents and purposes, it'll serve us okay through this class. And if you get in a technical situation, I lawyer up by saying consult with a statistician for an actual interpretation. But the p-value is what convinces me that I can make a decision based on that there is a relationship. The size of this is what I'm a bit concerned about in terms of like if I made an action on or something like that. Another thing I could go check out in terms of the size of the relationship or the size of the is this convincing enough? Like, would I make a decision on this model? Do I feel like attitudes towards women could definitively predict the whether you're a working woman or not? And in this particular case, I might go up to my R squared. How much variance is explained? And taking my R squared into account, I might say, look, these R squareds are actually pretty low. Like 6% of the variance is explained, 5% of the variance is explained. This isn't a particularly high predicting or high performing model. Now, it does have a statistically significant factor. That is, this is a statistically significantly contributing variable, but it doesn't really seem to be explaining a ton of the variation in the outcome. All right. So next part, Hosmer-Lemshaw. Okay, so I'll just rerun that regression. I'll toss in that Hosmer-Lemshaw test. Where was that? Options. Hosmer-Lemshaw. Okay. ROC curve. So I need to save my probabilities and then hit OK. And then I'll go on and make that ROC curve real quick. I think it's analyze and is it classify? Yeah, there it is. C curve, and I forget which one goes where. So this says test variable, move the outcome variable. So that's my been predicted, and then state variable. Wait, no. Test variable, that seems backwards to me. Yeah, outcome variable should be in the state variable. That's right. So outcome, and the variable that I'm testing is the predicted probability. That makes sense. ROC curve, diagonal reference line, perfect. Value of the state variable. It's going to be 1 and 0. Okay. And I can go down and glance at that ROC curve. Meh, looks okay. AUC looks pretty bad. But whatever. There's been worse in the world. And here's our Hosmer-Lemshaw. All right, finally, details on outliers. So it wants me to run another logistic regression. Well, maybe I should refresh my output. Normally, if I were doing this in a homework, what I would do is copy and paste the important output. That is, as I'm getting output that's answering these questions, I would copy and paste that into a Word file where I'm writing this up. In this case, again, I'm just going through quickly to focus on the interpretations. This isn't meant to be a guide on how to do your assignment or anything. So do be aware, like I'm kind of clicking through things and deleting output to make it cleaner. But what I'd expect you to do is if you're talking about this table, copy and paste this table into your output. Previously, I think I talked quickly about like the model R squareds and stuff like that. And if you did the same, then you'd copy and paste that into your output too. All right. So outliers, so I could do some studies on outliers. I'm not going to worry about that here. All right, so given all the information, so actually let's see, where's my outliers? Okay, so there's no outliers listed here. Hosmer, Lemshaw, so I don't have to worry about my outliers in the assumption. There were no outliers listed. Hosmer, Lemshaw is not statistically significant. So this is one of those tests where being statistically significant is a bad thing. That would indicate that my predictions are not performing particularly well. So I don't want this to be statistically significant. And so the fact that Hosmer-Lemshaw is not statistically significant is a good thing in terms of my observed versus expected. And then my ROC curve doesn't look particularly great. So given all this information, comment on my belief on the overall fit of the model. And the overall fit of the model also includes that R squared that I looked at earlier. I don't even know where to find that right now. Here it is. That R squared talks about overall model fit. All this comes into play that I don't think in the overall fit in terms of like assumption stuff. It doesn't seem to be anything wrong. Hosmer, Lemshaw, and case-wise output, there doesn't seem to be any like massive outliers or anything in the model. The zeros and ones and compared to the different categorized outputs seem to be reasonable. It doesn't seem to be drastically overfitting at any particular point. But it also doesn't seem to be performing particularly well. So that is, and talking about the fit, it really doesn't seem to be like there's any problems in the sense of I don't think that there's any outlier problems or any fitting problems in terms of like I guess an assumptions type issue. At the same time, and well, maybe I should just say in general in terms of a fit type issue, but at the same time, the model doesn't seem to be performing particularly well. And that is in a way an indicator of poor fit when fit is taken broadly. So that's probably how I would phrase my response here if I were talking about this is to talk about how the Hosmer-Lemshaw and the outliers seem to be doing good. And there doesn't seem to be any like major red flags or anything, but it's just that the actual result fit doesn't seem to be actually fitting the data particularly well. Good, borderline bad. Well, this doesn't really seem to be borderline bad. This seems to be pretty bad. 0.67, 0.68, maybe I'd call that borderline. But these are, for each of these statistics, again, Hosmer-Lemshaw and the outliers look good, but the AUC looks bad. All right. So this one, talking about the probability thing, maybe this is worth talking about. So for calculating the probability, maybe I'll go on and open a Word document here, and then I can kind of list in how I'm going to look at this. So I'm going to copy and paste this SPSS table. I'm not going to worry about formatting it or anything. Again, this is just a rough deal. And then I'm going to go, I believe I say, do the get the descriptives for all these variables, locus, attitudes, So descriptives, locus, all the attitude-y ones. I'll just run that. So here's all the descriptives, and here's all the means. So if I wanted to do, or what does it say? Use the values, calculate probability being employed if they provide an average response on each of the inputs. So what I'm going to do is I'm pretty much going to plug an average response for each of these into the equation. Now, what is the equation? Well, looking at this equation, I have my outcome, logit, is this stuff, or if I exponentiate it, I have the log of the outcome is this. So I'm going to write logit of y, that is work, yes or no, is that negative 0. Or excuse me, I'll do the constant first. So that's the intercept 3.197 plus negative 0.057 times locus of control plus 0.016 times attitudes current marital status plus negative 0.068. And I'm doing plus the negative just so you can see like all these are pluses. Really, these are just a minus. I don't write plus and negative normally. But attitudes for the role of women plus negative 0.028 times the attitudes towards housework. So this is the base logit model. And I can plug my values into here, each of these variables. And that's how you read these betas, y'all. So if you've forgotten how to read your regression coefficients, definitely go back and review some of your notes in regression from previous courses because that's where these come from, and this is important to be able to read. And this doesn't necessarily come specifically from this class. This is more from general regression. I could then plug in my average values for locus of control, ACMS, ARW, and ATH, and I'll actually go on and do that here. So locus of control, I'll just copy and paste this output too so that I have it handy. Locus of control had a mean value of 6.75. The two source current marital status had 22.9. Two source role of women, 35.12. And actually, interestingly, we interpreted this attitude towards the role of women as being relatively small, but the scale is on 35. So a single unit change in that scale is not particularly meaningful. I actually think this might be quite a bit bigger than what I implied earlier. So that's an interesting note here, and that's actually one of the good reasons to run a graph like this is a movement in terms of 10 might be more meaningful than a movement in terms of 1 within this context. Interesting. I kind of want to do the EXPB thing here. Let me pull up a calculator if it were 10. So I'm going to do multiply this effect by 10, negative 0.68, negative, and then I want to do e to that. Oh, crap. Do the 68 negative, enter. So 0.506. So that would be this exponent is doing e to that value right there. You know, I'm using my little dinky Microsoft calculator here. But that new exponentiated b would be 0.568, which is half of the odds. So that would indicate that for a movement in 10 on this scale, which seems very reasonable to be able to move 10 on a scale that goes from 18 to 55, movement of 10 on this scale would lead to about half of the odds of being a working woman, and that could indicate a pretty meaningful difference. So it's an interesting way to look at these descriptives. I think that's why it's important to look at the descriptives, and I probably should have before my interpretation, because again, it definitely changed the way I look at it. In any case, the last one, attitudes towards housework, is this 23.56. And so I'd plug this into my calculator, and what the heck, why not just do it, and then we can do it. 3.197 minus open parentheses 0.057 times 6.75 close parentheses plus open parentheses 0.016 times parentheses minus open parentheses 0.068 times 35.12 close parentheses minus open parentheses 0.028 times. Oh, me? Can I do a backspace? Oh, crap. Oh, yeah, that works great. 23.5604. That would have been awkward. Okay, close parentheses. All right, enter. So this is not my probability. This is my logit. And so if you remember from class, that logit, so logit work equals whatever that number is that I just got out of my calculator from this big, long equation here. And hopefully I typed that in right, because if not, that'd be really awkward. I can really quickly check. 3 minus, multiply things together, plus those two things multiplied together, minus those things multiplied together, minus those things multiplied together. Yeah, that looks right. Okay, cool. All right, so now I have to do this inverse logit, and we kind of gave the equation for how to do the inverse logit to just get work by itself. So work is going to be the inverse logit of 0.1322388. And how we do this inverse logit function is to, well, we had a big long equation. Ultimately, it involved taking e to that number divided by 1 plus e to that number. So this is the number that I want. And I'm going to do e to that number divided by 1 plus e to that number. And that's going to be my equation here. So I'm just going to figure out what the heck e to that number is. I'm going to just copy and paste this number, frankly. And I'm going to do e to the, and then I'm going to paste that number if I can, and hit enter, and I get this thing, which also looks long and nasty. This number divided by 1 plus this number. And now I can type that into my calculator, and I'm finally getting close. Let me clear this out. This number, let me do the denominator first. Well, I know what that is. This number divided by, parentheses, 1 plus, oh, I did, oh yeah, I did divided by. That's what I wanted to do. Thought I got lost. 1 plus this number, close parentheses, enter, and that gives me the probability of work. Predicted probability. Housewife. Average on all scores is, oh, nope, not that number. What did I just have? 0.53, about 53%. Cool. All right. Now that looks like a lot, and frankly, it was a lot. But what I want you to notice is I skipped over an easier way to do this, and that was using our odds ratio where I already calculated e to the stuff. So if I'd have used this odds ratio stuff, that would have made my life a little bit easier to be able to come in and accomplish this particular component. And I think we demonstrated how to do that. We had to note that this e to the was happening already. But what we did, in essence, and actually even if we kept this equation, it would have been fine. What we did is pretty much did e to the this right away. And instead of writing it in this format, we did e to the stuff on the right, and then the stuff on the left was the odds, and then we had this number that we could play around with a little bit, and this was in our slides. So this is the long, hard way to do this, but it's the most complete way that shows all of the possible work that you could possibly do. So that's why I included here. In any case, so now I have this. Am I surprised by the probability? No. I mean, what this would indicate is about, on average, about half and half for the average scores are working. I could go back to my table. Actually, I kind of want to do this. Let's do some descriptive statistics on the binary work status, and I just want to see how many actually are there. About 53% are working, and in this case, there's about a 53% probability that the women are working. So here it's exactly 53%. Ours is obviously a little bit off from that. So this doesn't surprise me at all, given the sample that I'm working with. This actually seems to make a ton of sense. Why or why not? Well, I'm not surprised because it matches the percent of working women versus housewives in our sample. Does it match the general probability of women? Well, yeah, exactly. Why do you think that is? Well, maybe you would think this is because the regression model fits it that way. Maybe you would think it's because it predicts really accurately. But again, in our case, we seem to suggest that maybe it doesn't predict really accurately, et cetera. So, that's something for you to think through. We're not going to actually talk through the technical reasons as to why that's so close, but that's something for you to think through and ponder a bit on your own. All right. Create another possible options. So what do I mean by create another possible options? Well, I have my descriptive statistics down here. Instead of just making up a number for, let's say, locus of control, I might go down here and say, well, the maximum locus of control is 10. What happens if I plug in 10 or 5? Now, if I change one of the variables, what I recommend you do is keep all of the other variables at their mean and just change this one and see how the percentage changes. So I might have, with maximum locus of control and everything else average, the probability is this. With minimum locus of control and everything else average, the probability is this. Same thing with the attitudes of, maybe I try attitude sorts role of women because it's the only statistically significant one. Maybe I do the minimum value and the maximum value and see how this probability changes for those. And again, I'd recommend just moving them on one variable. So if I did attitudes towards role of women, I would leave all of these other values set at their mean, and I would just change this particular one and see how it worked. All right, so the last part, putting in demographics and running your piece, I'll not do that. Pretty much what the demographics are going to do is potentially increase your prediction effectiveness, but ultimately you can still assess the contribution of your model. For which table to look at on how to do that, I encourage you to check out the SPSS video for the lecture set. But in terms of interpretation, all that really changes in terms of interpretation is when I'm interpreting the significance of something like locus of control. Now when I interpret that significance, I'm going to interpret it not just with the rest of the attitudinal variables included in the model, but I'm now going to interpret the significance of any particular variable with all of the other variables, attitudes, and all the demographics included in the model. So all the interpretation does change, but it changes simply by adding the component that we're accounting for this other information in the model. And this very well may change some of the statistical significances within your decisions. So again, this goes to the importance of when and why we discuss which variables are also in the model and how that changes the interpretation. Because we may have a variable that's statistically significant when X, Y, and Z are also in the model, but may not be statistically significant when X, Y, and Z are not in the model. So whenever we do an interpretation with the other variables in, don't forget the caveat. We're interpreting the effect of locus of control after accounting for attitudes towards current marital status, attitudes towards the role of women, and attitudes towards housework. And again, adding in demographics variables is going to change those interpretations pretty meaningfully. All right, well, I mean, this has been a lot more casual, and I mean, just screwing around a little bit here with your assignment, hoping that this helps. helps you to get some feel for what the interpretations are and could be, and understand a little bit better what we're talking about. And really, I hope what you're seeing is I'm just trying to go piece by piece through what I'm being asked to comment on and commenting on those. And then maybe if some of those comments overlap or could be phrased better, maybe I go back and in my write-up, I combine a couple of sentences to make it a little bit more efficient, a little bit more clean, a little bit more clear, so that it doesn't feel too piecemeal. Maybe I can practice writing a good professional level write-up. I think the biggest mistake I made in this, to be perfectly frank, well, I mean, I know I made a ton of mistakes, but the biggest interpretational mistake I made was interpreting the attitudes of roles of women, this exponentiated, this odds ratio, before looking at the potential movement, the odds ratio. I think we talk about in the video for the we talk about in one of our SPSS videos how to change the scale of the variable, and this one might be an interesting variable to change in a scale of 10. Again, well, but movement in 10, a single standard deviation is 6. Movement in 10 would be 2 standard deviations. That'd be going from like the bottom 5% in the variable to the top 5% in the variable. So 10's a massive movement. Maybe 10 is too much, but maybe a movement of 5 is reasonable. And so maybe we want to see what do these betas look like when the movement is 5. So something that's a little bit more than just the one that we naturally evaluate, because that could show something that feels intuitively a little bit bigger. Again, especially when the single unit increase is not particularly large or meaningful on the broader scale. To be quite frank, though, that's the whole purpose of this section of the assignment, is to practice doing what my favorite trick is with these type of variables and setting attitudes of the roles of women at the minimum and the maximum and seeing how the percentages and the predicted probability of being working versus a housewife change. Now, I don't tend to do minimum and maximum. I might do the mean, a standard deviation below the mean, and a standard deviation above the mean, so get some more reasonable values. Going from the min to the max is obviously a drastic change, but this is a good practice in that ultimate direction of how can we see what the practical effect is, and it doesn't force you to make a new variable with attitudes of roles of women divided by 5 or something to come up with a good interpretation. You can just plug in a couple of equations, and then you have percentages to play with and to discuss with your team, with your board, with your clients, so that you can more accurately and more clearly discuss the implications of what is the implication of attitudes towards the role of women on the outcome after accounting for all these other variables. So that's an important thing to note, and I think I feel a little bit bad about missing that, but now that I think about it more, actually, I'm not sure that there would be a good value to change that to, because 10 would be just too drastic of a movement here. I think. I guess not. It'd be about a 50% movement. It'd be going from the bottom to the middle and from the middle to the top. So 10 might be a lot, but it might be more reasonable than I first thought. Still, again, the point of running this part is so that you can actually pull the percentages and see what those impacts are. All right. Well, I hope you enjoyed it. I hope it was helpful. As always, email me if you have any questions, and don't wait till the last day to do so. And I hope you have a great rest of your day or night or morning.